All right, here's the free response question from 2019 at table. Has to do with velocity. The first question says, is there a time, at least one time, between 0.3 and 2.8 where the velocity, or the derivative of the velocity, which is acceleration, is equal to 0? This is the mean value theorem. So the mean value theorem is when the average rate of change equals the instantaneous rate of change. And if I look here for the average rate of change, it would be y2 minus y1. So in other words, it would be 55, take away 55. And then the denominator would be 2.8, take away 0.3. And when you answer that, the answer is 0. So for the average rate of change is 0, then there must be at least one time where the instantaneous rate of change or derivative is also 0 if it is differentiable and continuous, which it is. So here's the average rate of change. So we just write that down. Since the velocity is both differentiable and continuous, and the average rate of change from 0.3 to 2.8 is 0, there must be at least one time that the derivative is also equal to 0. Done. And that's called the mean value theorem. All right, let's look at part B. You can press pause if you need to. In part B, again with calculus, we're looking at derivatives and looking at integration. Off a table, if you're going to integrate off a table, they're going to either ask you for a trapezoid sum or a Riemann sum. So in this case, it's a trapezoid sum. And it says use a trapezoid sum using those intervals to integrate from 0 to 2.8. So I'm going to write down what we're doing. We're going to integrate from 0 to 2.8 the velocity, and we're going to use a trapezoidal sum in this interval. So to start with, for a trapezoid, it's 1/2. Then the base is t. So from 0 to 0.3, the distance is 0.3. And then we add the two heights, which are 0 plus 55. And I'm going to follow that pattern. So I'll show you my work, but I'm going to follow that pattern. So again, we're going to go 1/2, and then the distance again between the two, it's from 0.3 to 1.7. So that's 1.4. And then add the two heights, which are 55 and negative 29. We're going to do that again one more time. From 1.7 to 2.8, the distance is 1.1. And then add the two heights, which again are negative 29 plus 55. Now, I don't have to summarize it. I don't have to add it up yet. That's a full answer right there. So part B is done. Part C. This is what's going to require a calculator, so that's why you see Desmos up here. So I'm going to use Desmos to support here. So it says particle Q also moves along the x-axis and has this velocity, but it's given as an equation rather than a table. Find the time interval which the velocity is at least 60. That means 60 or more from 0 to 4, and then find the distance traveled. So we'll do the first part. I'm going to type this into Desmos. So that's 45 the square root of t cosine, let's say cosine, cosine 0.063 t squared and then I'm going to integrate it. oh sorry, I'm going to graph it. There it is. I see the graph. But it says just from 0 to 4. So that domain restriction is going to be important. So to do that domain restriction for t from 0 to 4, that's how you type in the domain restriction. And then the second thing I need to know is 60. So I'm just going to type in y equals 60. And I'm going to zoom out, and then I'm going to see, okay, I'm going to see where the 2, and I'll zoom in here so you see it. So here's the velocity. It's at least 60 when it's above that line of 60. So that would be from 1.866 to 3.519. I'll show you what I'm writing down right now. So it's 1.866 to 3.519. So this is what I'm writing down. So this equation's greater than or equal to 60 from there to there. Then it asks, find the distance traveled. So to find that distance traveled, that's an integration question. We're going to use those as my bounds. So 1.866, 3.519, and we're going to integrate that velocity for q. And let's see what that would look like. So I'm going to go functions and then go down to calculus, and I'm going to type in those bounds 1.866 and 3.519. Now I'm not going to type in that whole equation. I'm just going to go via t. So I've already defined it, and then see what the answer is. So the answer is 106 point, and it's always 3 numbers after the decimal. You don't have to round. So 3 numbers after the decimal, and you don't have to round. So this is what it looks like. So using the calculator there, like this. All right, part C is done. All right, one more part, part D. In part D, it says at time t equals 0, particle Q, that's part C there, is at position negative 90. Use the result from part B and the function that we did right now to approximate the distance between the particles at 2.8. So if I read that again, I need to know the position of each particle and subtract to know the difference between them. So how do I figure out what the position is for each one? So I'm going to start with Q. So to do Q, it starts at negative 90. So I'm going to write down negative 90 plus, and then I'm going to integrate to find its position. And the bottom bound is going to be 0, and then my top bound is what I'm looking for, which is 2.8. And then I'm going to subtract. And then I'm going to find the position at 2.8 here using this table, what we did here. So the particle P starts at 0, not 90. So if you want the template, it'd be 0 plus, and you integrate. And then 0 is my bottom bound. So the origin is 0, and 0 is my bottom bound. Then what I'm looking for, which is 2.8, is my top bound. And I write down that's the velocity for P. Let me just show you what that looks like. So it starts at negative 90 at 0, and we're going to integrate up to 2.8 with our calculator to figure out what distance, where the position is. Same thing here, it starts at 0 times 0, and we're up to 2.8. We're going to do this off the table, and we subtract to see what the difference is between the two positions. So I'm going to type this in the calculator right now. All right, I'm I'm going to clear this. I'm going to keep this up there because that's helpful that it's already defined. And I'm going to start typing. So I'm going to use parentheses, negative 90, plus, I'm going to integrate. So I'm going to go to functions, down calculus, down here. And then my bounds for the first one was 0 to 2.8. And that's the function up there. So I'm just going to call that v at t dt. Then I'm going to close the parentheses and then subtract and open up a new parentheses for the second one, which is 0 plus. Now, for this one, I'm going to do the Riemann sum that I didn't calculate out. So if you go back to part B, I'm going to just type in exactly what part B is. So I'm going to do that now. So in part B, 0 to 2.8 was 1/2. I'm just going to put in 0.5. And then 0.3. And then 55 plus 0.5, 1.4, 55 take away 29. There it is. One more plus 0.5. Again, I'm just copying part B. 1.1, negative 29 plus 55. And I have my answer. So the difference between them is 5.187 or 88, but either is perfect. I don't want to round. I don't want to think about it. You can truncate, which means just write down the 3 numbers after the decimal and you're done. So 5.187. Oh, that was part B here. There were no units in the question, I don't believe. Were there units in the question? No. So there's it. If there were, oh, there is units. It's meters per hour. So this answer would be meters. And it's smart to go back and go, is there another one where I didn't include units? So I did include units here. This one, when I integrated velocity, the answer is just the unit, which is meters. This would also be meters. Part B, go back, and we're good. All right, Mr. G Math over and out. I'm proud of you. I know it's not easy, and sometimes you got to watch it twice. Try it again on your own, and really work to understand it. Till next.